Hello guys, welcome to a new video. In this video we will explain the exponential laws, so stay with us and let's jump into the computer. Firstly, we have 9 laws in exponential laws. The first of them is when we have a variable or we have a number and this number or variable is raised to the power of 0. When we have any number or any variable raised to the power of 0, it equals directly 1. Let's take an example. If we have 5 to the power of 0, it's equal 1. If we have 3 to the power of 0, it will be equal 1. If we have 100 to the power of 0, it will be equal 1 too. If we have 2/3 to the power of 0, quantity to the power of 0, it will be equal 1. If we have e to the power of 0, it will be equal 1 too. This is the first law. It is very easy. Now let's jump to another one. The second one is when we have a variable or number and this variable or number is raised to the power of 1. If that is the case, the number or variable that raised to the power of 1 is equal the base. Let's take an example here. If we have 5 to the power of 1, it will be 5. If we have 20 to the power of 1, it will be 20. If we have x to the power of 1, it will be x. If we have 200 to the power of 1, it will be 200, and so on. Now let's jump to the number 3. The law number 3 is when we have two bases, they are the same, but they are raised to the different power. Let's take an example. If we have 5 to the power of 3 multiplied by 5 to the power of 2, the answer will be 5 to the power of 3. We add this power to the other power of 2, it will be 5 to the power of 5. So when we have two same bases multiplied by each other, then we put the base here and we add the two power to each other, or the two exponential to each other. If we have 100, if we have 100 to the power of 10 multiplied by 100 to the power of 2, it will be 100 to the power of 10 plus 2, it will be 100 to the power of 12. Yeah, and so on. Now let's jump to the law number 4. It is very easy too. If we have two variables or two numbers, they are the same base, but they have different power. The two of them rise to a different power, but here instead of multiplying the two variable, we here divide the two variable on each other. So instead of adding the powers to each other, here we will subtract the second power from the first one. Here we will be subtracting the second power from the first one. So let's take an example. If we have 3 to the power of 8 over 3 to the power of 5, it will be equal 3 to the power of 8 minus power of 5. It will be 3 to the power of 3. If we have 10 to the power of 2 over 10, here it will be 10 to the power of 2 minus 1, so it will be 10 to the power of nothing, because 2 minus 1, it's 1, and 1, we don't type 1 like that. It's obvious that when we have nothing here, it will be 1. Now let's jump to the rule number 5, which is when we have a different bases here, but they are raised to the same power. What we do here? Let's take an example. 5 to the power of 3 multiplied by 3 to the power of 4, to the power of, have the same power, to the power of 3. That means we need to multiply two variables or two numbers together, and the exponential or the power stay the same. So it will be 15 to the power of 3. The same here, if we have 10 to the power of 2 multiplied by 40 to the power of 2, it will be 400 to the power of 2. It's very easy. Let's jump to the number 6. The same concept, but instead of multiplying here, we will divide the two variables from each other. So if we have 5 to the power of 3, like the previous example, and we have 3 to the power of 3, it will be like 5 on the power of 3 quantity to the power of 3. So they are raised to the same number. So let's take another example. If we have 10 to the power of 5 and 5 to the power of 5, it will be equal 10 over 5 to the power of 5. And 5 we have 1 here, 2, it will be 2 to the power of 5. Yeah, it's very easy. Let's jump to rule number 7. The rule number 7, when we have a variable or number raised to any power, and this variable number that rises to any power have a quantity, and this quantity rises for another power. So what we need to do here, let's take an example. If we have 2 to the power of 4 quantity to the power of 5, that's mean we have now we need to multiply this 5 with this 4, so it will be like that, 2 to the power of 20. If we have 10 to the power of 2 quantity to the power of 10, it will be 10 to the power of 22. Now let's jump to the other law. This law says that when we have a negative power, what we should do. Let's take an example so it will be more clear. If we have 5 to the power of 2 of negative 2, that means it's the same like 1 over 5 to the power of 2, because this here is like a reverse of this one. Let's take another example on, let's say we have 6 to the power of negative 3. It will be like we have like this, 1 over 6 to 6 cubic. Yes, this is the rule number 8. Now to the last one. This is the last rule that we need to explain more. In this rule, it is the rule that we can with it convert an exponential number or an exponential variable to a root or a radical. So what we need to do when we have a variable that rises to the power that is a fractional power, like this one, p over c, the c will be the power of the root and the b will be the power of the base, like here. So let's take an example. If we have 7 to the power of 2/3, that means we have, it is the same like saying we have 7 to the power of 2 under the root, or under the cubic root. This 3 will come here and this 2 will be here. Yeah, that's just for explaining. Let's take another example. If we have 100 to the power of 2/5, it will be like the same saying 100 to the power raised to the power of 2 under the 5th root. Yeah, this is the last law, and it is important. This rule is very, very important in solving equations, because there are many equations. The hard one, that you have exponential and have a radical root, and you need to make them all roots or all exponential in order to solve this equation. That's why this rule is very, very important. And we have a last tip. It's important. These two laws does not exist. We don't have, in exponential laws, we don't have addition or subtraction. So that was our video for today. Thank you very much for watching, and see you in another video.